Hi, this is the Algebra 1 Unit 6 Lesson 4 video. This lesson is pretty straightforward. There's some vocabulary and then some kind of basic information about what we call transformations of quadratic functions. So I'm actually going to go ahead and open the Desmos calculator here because I want to kind of illustrate some of these concepts for you so you can see how each type of transformation works. So when we talk about a transformation of a quadratic function, we're talking about some change from the basic function. So for instance, the basic function of quadratic functions is y equals x squared. My video over here. Make it smaller if I can. Nope. So y equals x squared is what we call the parent function, and you've seen this in the previous videos. So when I say it's the parent function, I mean that it's kind of the starting point for all of the other types of quadratic functions. Jumping back over to the lesson page, the first 5 questions on the lesson are going to be your vocabulary. So I'm going to go ahead and leave you to that. So just match up the correct vocabulary word with these 5 blanks. And then it gets us into some things about what types of transformations are being done to these different graphs. But before we get there, I do want to get a little bit more in depth than what is done in the unit, because I think it's important for you to understand how this works. So I've put in the notes some images here that look at different changes to the graph. So again, the basic graph of the function opens up and it is y equals x squared. And then what I do is in each graph, I change something about the graph, about the equation, and then we look at how the graph changes based on that. So I'm going to walk through these examples, but I'm going to do it on the Desmos screen so you can actually see how this kind of plays out. For instance, the first type of transformation that I'm going to show you is what we call a reflection. And an example of a reflection in this case would be this. Y equals negative x squared. So you can see that the graph of the function right here, the original function in red, has been reflected so that it is now below the graph. And let me close this. There we go. And now you can see we've got y equals x squared, y equals a negative x squared. So putting a negative in front of my function means that the entire graph is reflected downward along this x-axis. It's as if there's a mirror along this x-axis and the graph's been reflected down there. That's what you see here, opens down. This is an example of that. So that's a reflection. That's the first type of transformation. That's blue, or that's in blue here. Let me erase that now. Let's go back to my parent function. Let's say that I add a number to my parent function. Let's add 4. Okay. So what's happened here is that starting from my parent function in red, if I add 4, the graph moves up 1, 2, 3, 4 spaces. It moves up 4 spaces. So by adding a number onto the end of the function, I shift the graph up however many units. So if I change that 4 to a 7, it moves up 7. If I change it to a 1, it only moves it up 1. 3, 5, whatever it is, if I change by adding something onto the end, the graph moves up. That's called a shift or a translation in the lesson. So it's a shift upward. Now you can probably guess what's going to happen if I do minus 5, for instance, or minus 8, or minus 12, or minus 3, minus 4. In all of those cases, the graph is being shifted down from the red graph to the blue graph. It's being shifted down this many units. And that's what you're going to see down here. We have a shift up and a shift down here and here. All right. Now let's look at what happens if I do another type of change. For instance, what if I were to add something to the x, not to the entire function? Now I'm adding something in here to my x value and then still squaring it, but I'm adding it to just the x value. When that happens, we get a horizontal shift, also a translation, but a different type of shift. And here the graph is shifting to the left. From the red to the blue, it's being shifted, in this case, 3 units. Or maybe I change it to 8, or just 1. Whatever it is, the graph is being shifted to the left 7 units in this case, because I'm adding 7 to the x value. Again, you can probably guess what's going to happen if I change that to a minus. If I subtract a number to the x from the x, it shifts the graph to the right that many units. Again, if I do an 8, a 3, a 2, every time it's shifting to the right that number of units. Jumping back to the notes page, if I go down to the second page here, this is what I see here. I have a shift to the left and a shift to the right. Plus shifts to the left, minus shifts to the right. And let's look at one more type of transformation. Let's go back to our x squared graph. Notice they're the same right now. And one other type of thing I could do is I could multiply by something. So what if I multiply by 3, or by 7, or by 23? And you'll see in each of those cases, whatever that number is, the graph is what I would call narrowing. So this graph in blue is more narrow than the original graph. So when I multiply by a number, specifically anytime I multiply by a number that's greater than 1, I'm going to narrow the graph. Notice I said greater than 1. What happens if I multiply times a decimal? Or a fraction, like 1/3, or 1/7, or 4/7. All of these examples of things that are less than 1. Well, when I do that, the graph is widening. The graph here is wider than the red graph, because when I multiply by a number less than 1, the graph widens. And that's what we have in my example down here. Narrow is greater than 1, wide is less than 1. And what's great is that you can actually combine all of these things into one type of shift or one type of transformation. So for instance, I could have a graph that says 3 times x plus 6 squared minus 2. Okay, so let's look at this and say, how did I get from this red graph, the parent function, to the blue graph? What has changed in this? Okay, so I'm going to open up my little note-taking app real quick. Let's go back. Let's close that. Let's get a new one going. And let's write down this equation that I just wrote in. 3x plus 6 squared minus 2. All right. Y equals 3x plus 6 squared minus 2. So let's say what is going to change about this graph? Okay, so based on the information we just went over, this first thing is going to tell me whether or not the graph is narrow or wide. So because it's greater than 1, this graph is going to be more narrow than the parent function. What about this? Well, we know that when we add a number to x, and it's plus 6 in this case, it's going to shift, shift 6 to the left. Lastly, we know what happens when I add or subtract a number to the end. In this case, the graph is going to shift down 2. We see here that that's exactly what happened. I'm going to take a screenshot of this before I get too much further. Put that on our that graph on there for us. Okay, so that would be what happens when we have that type of graph. So let's look at another example. What if my graph was y equals negative 1/3 x minus 1 squared plus 8. Okay, there's a lot going on in this equation, but we know what each one of these things tells us. For instance, we know that there are actually two things coming from that piece of information. Let me go ahead and do two things. First of all, this tells me that the graph opens down. This number, being less than 1, tells me that the graph is going to be wide or wider than the original graph. This right here tells me that the graph is going to shift to the right 1 unit. Lastly, this tells me the graph is going to shift down 8 units. So notice we didn't even look at the graph. We just looked at the equation and determined what each piece of information tells me. So let's take this and put it into Desmos and see if we were right. Let's go back here. Negative 1/3 x minus 1 squared plus 8. All right, now let's look and confirm that all the things we said would happen happened. The graph opens down. Oops. The graph opens down. The graph is wider than my original graph. The graph has been shifted down 1 unit. Oh, Mr. Matthews messed that up. Sorry, to the right 1 unit. From here to here, you can see that point right there. I'll actually go ahead and highlight that point so you can see. Look, 1 to the right. Also, it's been shifted. Oh, and I really did mess that one up. You probably were wondering where I got that from. That should say up 8 because it's plus. Missed that completely. I make mistakes too. So it's been shifted up 8. And when I say it's been shifted, just so it's clear, we're saying we are going from this point right here. We're going to the right 1 and then up 8. And that's the shift that's occurring. And that's what we mean when we say that here. Okay, so that's pretty much an overview of what you need to know. You actually don't even need to know that much. So let me jump over to the lesson and let you see. There's a summary of what I just went over right here, but I think you'll appreciate having these example graphs and the examples we did on the lesson notes. But down here is number 3, 4, and 5. All they want you to do is look at the graphs and determine which type of transformation has occurred. So looking at the solid line to the dotted line, what happened? Was this a translation, a dilation, or a reflection? Oh, sorry, a dilation is going to be, let me erase this over here. I should have said that. It's my apology. A dilation refers to a narrow or widening. So anytime you have that, that's what a dilation is. So that's what you're going to look at there. Same thing here. What has changed? I would focus in on this information that you see right here, but even just looking at the graph, you can tell what's happened. And then lastly, what's happened here between this graph and this graph going up and this graph obviously going down. Is that a dilation, reflection, or translation? And that's pretty much it. So you've actually gotten more information than you need, but I think it will come in handy as we keep going through this unit. But that's it for lesson 4.